Hi everyone, in today's video we are going to look at some applications of difference of two squares. Okay, so if you remember from our previous video where we learned about the concept of difference of two squares, we made mention of this particular formula that if you have a squared minus b squared, it can also be written as a plus b in one bracket multiplying a minus b in another bracket. Okay, so we used it to solve certain problems like these ones. Okay, but in today's video we are going to look at some applications. We have factorizing algebraic expressions, so you can use the concept of difference of two squares to factorize algebraic expressions. You can also use it to solve certain equations, to simplify certain fractions in algebra, and then also to perform some mental calculations. Okay, it's kind of a shortcut to perform some calculations. Okay, but this video will focus more on the first one, which is factorizing algebraic expressions, and subsequent videos will look at the other ones as well. Okay, now there are a couple of things you're supposed to know when you are using the method of or the principle of difference of two squares to factorize algebraic expressions. The first one is that this method works for only two-term algebraic expressions. So in other words, you can only use or apply difference of two squares to factorize algebraic expressions if they only contain two terms. Okay, and usually either the a or b or both a and b are replaced with variables. Okay, so instead of seeing a squared minus b squared, you may be seeing other variables like x or y or x and y. Okay, but you can also see other letters being used as variables as well. And to factorize completely, you need to make sure that the terms in the brackets cannot be factorized further. Okay, so for example, if you take this equation we have at the top here, a squared minus b squared equals a plus b in one bracket, a minus b in another bracket. This is completely factorized. Okay, so you make sure that the terms in the brackets cannot further be factorized. If you derive any answer and the terms in the brackets can further be factorized, then you've not factorized completely. Okay, so let's look at some examples. So we'll be using these examples to look at how we can factorize algebraic expressions by applying the principles of difference of two squares. Okay, so the first example is x squared minus 25. Okay, so if you remember our formula, you're supposed to make sure that we have two squares and then a minus sign between the two. Okay, so x squared is already x squared, so we don't really need to worry about that. But 25 is not x squared, right? So we have to make sure that 25 is written in the form of a square. Okay, so 25 can be written as 5 squared. Okay, so that means we can rewrite x squared minus 25 as x squared minus 5 squared. Since we now have difference of two squares, we can just recall our formula. Okay, and then based on that formula we can rewrite x squared minus 5 squared as x plus 5 in one bracket, x minus 5 in one bracket, and this will be our final answer. You can see that the terms in these two brackets cannot further be factorized, so this is the simplest form we can get it. Okay, you can also write it in this form. Okay, it's the same thing, just that for this one the positive one comes first, whereas in this one the term or the bracket with the negative sign comes first, but it's basically the same thing. Okay, the second example, we have 9a squared minus 16b squared, and we have to factorize it completely. So first of all, you have to make sure that the two terms are written in squares, right, to make our work easier for us. So if you take 9a squared is a single term on its own. Okay, so we want to rewrite 9a squared as a square, like the whole of it as a square. Okay, so we know that 9 is equal to 3 squared, right? And a squared is already a square, so we can rewrite the whole of 9a squared as 3 squared multiplying a squared. And by the principles of indices, right? If you have two squares multiplying, it's the same thing as the bases multiplying, all raised to the power of the same digit. Okay, so basically, let me quickly illustrate that one here. So basically, if you have something like a to the nth power multiplying b also to the nth power is the same thing as a multiplying b, so that would be ab all to the nth power. Okay, so we are just applying that to simplify or to get the square for this particular term. Okay, so that means we can write 3 square a squared as 3a all raised to the power 2. Okay, so that means 9a squared can be written as 3a all to the power 2. Then for 16b squared, 16 can be written as 4 squared, and b squared is already a square, so just following the same principle, we can write 16b squared as 4b all to the power 2. Okay, so combining the two, we can write 9a squared minus 16b squared as this whole new expression. We just replace 9a squared with a 3a all squared here, and we replace 16b squared with 4b all squared over here. Okay, now that we have a difference of two squares, we can recall our formula and then follow that method and use it to factorize further. All right, so we are going to have 3a plus 4b in one bracket and then 3a minus 4b in another bracket, and this cannot be simplified further, so that will be our final answer. Again, you can rewrite this in a difference form whereby the expression with the minus comes first, but it's not really important. It's just that you can rewrite it in different ways. Okay, so that will be all for the second example. We move on quickly to the third example, where we have 1 minus x to the fourth power, and we have to factorize this completely. 1 is the same thing as 1 squared. X power 4 can be written as, remember, we want to get x square, right? So a difference of two squares. We want to get a square from x to the fourth power. Okay, so x to the fourth power is the same thing as x squared times x squared, and x squared times x squared can also be written as x squared all to the power 2. Okay, so that means you can rewrite 1 minus x to the fourth power as 1 squared minus x squared all to the power 2. Okay, and we recall our formula and we break them down to this. So usually you would have probably concluded that is the answer, but this is not really the final answer, because you can also factorize 1 minus x squared. Okay, so the term in the second bracket can further be factorized. We have to do that because we've been asked to factorize completely. Okay, so you can factorize 1 minus x squared again, but we cannot factorize 1 plus x squared because it's a positive sign between the two, so we don't have a difference for the first bracket, but we have a difference for the second bracket. Okay, so we proceed to factorize 1 minus x squared, and that is going to give us 1 plus x in one bracket and 1 minus x in one bracket, and this will be our final answer. Again, you can rearrange them. Okay, you can choose to bring the second bracket first, followed by the last bracket, and then this one follows. Doesn't really matter. Just make sure that the terms in the bracket are correct, and that will be all. Okay, the fourth example we have is x squared y to the fourth power minus x to the fourth power y squared. we have to factorize this completely. So for this particular example, we are going to have to kind of factorize the common terms for the expression, for the whole expression. What I mean by that is that we can factorize, so we can see that for this whole term we have x squared and then y to the fourth power. For the second term we have x to the fourth power and then y squared. So there are common terms we can factorize from both sides, right? So we have to do that, and the reason why I have to do that is because it makes our work easier for us. Okay, remember the goal is to factorize, but sometimes you don't just begin to use the difference of two squares, right? I mean, we can decide to use difference of two squares right from the start, but that will probably make the work a bit difficult for us. Okay, so what we are advised to do is that you first of all have to check if you can factorize common terms out first before you can proceed. Okay, so we can factorize x squared y squared from both terms, and that will give us y squared minus x squared in this bracket, and that is a difference of two squares. Pretty simple to use the principle of difference of two squares to factorize that one. Okay, so now we focus on that one, recall our formula, and we can rewrite y squared minus x squared as y plus x, y minus x in separate brackets, and that will be our final answer. Okay, but if you want to use difference of two squares from the start, then you take each term. This is x squared y to the fourth power. You can rewrite them as that. Then you rewrite the y to the fourth power as y squared to the second power. So x squared y to the fourth power can now be written as this. Okay, remember you want to get difference of two squares. Then you do the same thing for this term as well. Okay, so eventually you can rewrite that also as this. Then you get this, right? So now we have difference of two squares. This whole thing squared, this whole thing squared. You recall your formula and then expand them. But once you get here, you're not done. Okay, you're not done. You're not really done. The reason why you're not really done is because there are still terms in both brackets that you can factorize out, and that is what we did for the first step before we proceeded to apply the difference of two squares. But here we are applying the difference of two squares first before factorizing those common terms out. So we proceed to factorize xy from both brackets. Okay, and subsequently we can now factor out xy. So we factor out xy from this whole square bracket and then another xy from this whole square bracket. So you end up having two xy's in two separate brackets, and then y plus x, y minus x also in their separate brackets. And this is the same thing as xy to the second power, and that will probably also give you the same answer as the one we had in the previous slide. Okay, so this is what we bring to this video to an end. You can try this and leave your answer in the comment section, and I'll see you in my next video. Thank you and goodbye.